the -6 out just to apply the formula.
So the n is going to be like a -7.
Correct, that's right.
Plus 1.
That's right. So I raise it up to 1. I raise it by 1, goes to -6, and divide by the new power. Okay? You're always dividing by the new power, as opposed to the derivative, right? You're multiplying by the old power. Your work in Chapter 5 will be greatly diminished if you practice these problems very well right now. A lot of Chapter 5 is this kind of work, finding antiderivative. It'll relate it to geometric things, but ultimately you're taking a lot of antiderivatives. So 4 root x, we have this symbol already for us. 4 root x minus 4 over root x. Okay, the other thing you should know about this operation called antiderivative, not only can you pull out constant multiples just like a derivative, you can also split up sums and differences. So I could write this right now as antiderivative of 4 root x dx minus antiderivative of 4 on root x dx. You see what I did? Those of you who are not as familiar with antiderivative. Split up 2 cases. Not only that, but the 4 on each of these can come to the outside. They're both constant multiples. So I can write this as 4 integral root x dx minus 4 integral 1 on root x dx. So those of you who are very familiar with antiderivatives, I'm going like the slowest route possible. All right? Those who are not familiar with it, it might be helpful to think like this at first. All right, I'm going to change these radicals to powers because I have a rule for powers for antiderivatives. So I'll write it now as 4 antiderivative of x to the 1/2 dx minus 4 antiderivative of x to the -1/2 dx. There's no advantage to having this 1 over x to the 1/2. There's no advantage. You want it as x to some power, not 1 over x to some power. So I went ahead and moved it. Now just apply the, I'll call it the reverse power rule, right? Let's do power rule reverse, right? Your antiderivative power rule. So it's going to be 4 times x to the 1/2 plus 1. 1/2 plus 1 is 3/2. So you're going to have x to the 3/2. Now I'm going to divide by 3/2. That's the same as multiplying by 2/3. So rather than write complex fractions, like fractions of fractions, stuff like that, which is really unnecessary, just always take the reciprocal of whatever the new power is. So 2/3 in this case. Minus 4 times x to the what? I got to raise -1/2 up by 1. So that puts it at 1/2. Now I'm going to divide by 1/2, which is the same as multiplying by 2, right? Multiply by 2. So there's our expression. We need to simplify it a little bit. So 4 times 2/3 is 8/3. We have 8/3. X to the 3/2 minus 8 x to the 1/2 plus c. I really should have written plus c up here, more appropriate. Once the indefinite integral symbol is gone, you should have a plus c at that stage. As long as you append it at the end, I don't care so much. Just make sure you have it at the end. Yeah, tell me. Yeah.
When you multiplied 4 times 2 to get -8, where did the 2 come from?
This 2?
Yeah.
Because the power rule for antiderivatives is I raise the power up by 1,
Oh, okay.
and then divide by the new power.
Okay.
So divide by the 1/2 is multiplied by 2. 29.
Hold on. When you add the 1, shouldn't that be a half because that's a -1/2?
Yeah, that is what it is. Over half for the new power. Then you're dividing by half. So that's multiplied by 2.
Oh.
You're always dividing by the new power.
Dividing by the new power. Okay.
Dividing by the new power. So that's a multiplying by 2 in this case. Dividing by half is multiplied by 2, right? Yes, reciprocal. Multiply by the reciprocal. Secant squared x minus 1. Find the antiderivative. So what's the antiderivative of secant squared? We can split this up into, there are two cases. Even if we don't do it officially, I'll do it officially. I'll do it officially anyway. So I have secant squared x dx minus antiderivative of dx, or 1, I'll put 1 in there just for fun. So what's the antiderivative of secant squared? Tan. You differentiate tan to get secant squared. So we have tan x. What is the antiderivative of 1?
X.
Right. Good, x. So now the 1 does not have to be present. So anytime you have this expression, antiderivative dx, the answer is x. The 1 does not have to be present. Okay? So minus x. See? There's our answer. You guys following okay or not? Okay?
So,
Somebody say so?
yeah, just looking at the power rule, you took.
Say again?
So you added 1 to on
Add
top.
1 to the 1/2.
Okay.
Which made it 1/2. And I divided by 1/2.
Like when we wrote out the formula for it, it was like n plus 1 over.
X to the n plus 1
X-
over n
n.
plus 1.
So that should have been 1 plus, and that's 2/3 because you flipped it, right?
This one.
Yeah.
Yeah, they're both the same thing. The 1/2, I raised up by 1. So 1/2 plus 1 is 3/2. It's 1/2. Then I divide by 3/2. So that's the same as multiply by 2/3.
N represents a power, right?
N represents the original power inside the integrand.
Okay.
Yeah. Yeah, sorry. The inside of an integral is called an integrand. All right. So number, what I say? 32. 32 is sine minus 1 over cosine squared. E theta. Those are thetas, not euros. Thetas.
What's a zero?
What's that? I just said it was, so it must be. I wouldn't
Looks
lie
like
to
a
you.
G.
Yeah, we said this last time
Right.
on the
that's a
first
G.
day of class.
That's right. That's my theta.
That's a G.
Doesn't matter what, as long as these match up with that, you guys are okay. Alright? What told me? I don't care. Whatever it's called. Okay, so what are you gonna do with this one? You don't know a derivative as this. You don't know any function you take derivative of and you get this crazy little thing, right?
You know you have to use the quotient. It has to be subtracted because it has a quotient rule in it, right?
Oh, interesting thought. The problem is, undoing a quotient rule is very difficult. And you don't have a technique for that. So what we're going to do is a much more obvious thing than trying to undo a quotient rule. We're going to split this up into two cases. So you have sine theta over cos squared theta minus 1 over cos squared theta. Split into two fractions. Right? So how can you reduce sine theta over cos squared theta? How could you write that? Because you still don't know anything that looks like this either. You don't know any derivative that looks like sine on cos squared. I'm not going to use substitutions yet. I'm not going to use substitutions. Those tan times what? Right. What's the secant tan? Everybody agree?